Hi there. In this video, we're going to talk about percents. And what is a percent? A percent is just a part of something divided by a whole amount of something. All right, so you might be computing the percentage of gas left in your gas tank. So it's the amount of gas divided by the volume of the gas tank, how much possible gas there could have been in there. You might be looking at in a gumball machine, the percent of gumballs that are blue. So you take the number of blue gumballs and divide by the total number of gumballs. That gives you a percent. So let's look at this example here. All right, it says 145 out of 200 people say they like chocolate ice cream. What percent is this? So the part is the 145 out of a possible 200. So when I compute the percent, I'll just take the part divided by the whole. And when we make that computation, we can compute it as a decimal if we want, and you would get 0.725. So this can be viewed as a percent. Now what you'll see people do often is they'll write a percent symbol next to it. If you write a percent symbol next to it, you have to multiply it by 100. So, and by the way, multiplying by 100 just moves the decimal place over 2 spaces to the right. All right, so when you see the percent symbol over here, you should always think of this as a decimal where we've moved the decimal place 2 units to the left. So as a decimal, it would look like this. As a percent, it would look like this. And so you can think of the percent sign as the number 1 over 100. If you multiply something by 1 over 100, that does exactly this. It would move the decimal place 2 units to the left. And so you'll see percents written both ways. But keep in mind, whenever you have a percent sign here, the decimal place has been moved 2 units to the right. Okay, so in these next problems, we're simply going to write these numbers as percents. So I have 1 divided by 5. Well, if I write that as a decimal, you see you get 0.20. And if I wanted to write it as a percent with a percent symbol, I would write that as 20%. Okay, let's go to the next one, 0.03. Well, I've already expressed it as a decimal. So what we can do is we can write it as a number with a percent sign. So I'm going to take that decimal point, move it two positions to the right, and that's my percent. As you can see, we just get 3% on that one. What about 3.14? Well, again, as a percent, I'm going to move that decimal point 2 units to the right. And there's my percent, 314%. Okay, let's take a look at these problems. Here, we're given a percent, and we want to write them as a decimal. All right, so remember that the percent sign means to move the decimal place 2 spaces to the left. So if I were to write this as a decimal, I would write it as 1.37. And over here, the 6%, the decimal place is right after the 6. We don't write it when it's right there, but that's where it is. We're going to move it 2 spaces to the left. So as a decimal, 6% is 0.06. And what about 0.2%? Well, if I move that decimal place 2 spaces to the left, we get 0.002. Okay, well, we said that percent is equal to part divided by whole. Well, we can rearrange this equation a little bit using a little bit of algebra. We can solve this for part. So I would multiply both sides by whole. The wholes would cancel on the right, and I would get part equals percent times whole. So that's the same equation, just using a little bit of algebra. We've re-expressed it so that part is on the left-hand side. And we can use this to compute percentages of things. So if I want to compute, say, well, in this example, sales tax is 8.5%, how much tax would we pay on a $42 purchase? And this formula tells us exactly how that works. The part is going to equal the percent times the whole. Now, when we do this, we always want to write percent as a decimal. Whenever we use it in a computation, we're going to take that percent sign off, rewrite it as a decimal, and use that in this formula. And so let's go ahead and write this out. The part that we're going to pay is the tax. So in place of part, I'm going to write tax. And the percent, as we said, we're going to write this as a decimal. So I'm going to move that decimal place 2 spaces to the left. So I get 0.085. And then I'm going to multiply this times the whole amount, which is $42. And when we do this computation, we get 3.57. Now, if I kept track of units, you'd see I have the dollars up here, and so this is still dollars over here. So it's $3.57. That would be our tax. Okay, in this problem, we're told that tuition is expected to increase by 6% next year. If tuition this year was $2,000, what will it be next year? So we got to think a little bit more here. We want to increase the tuition. Well, we don't want to, but that's what's going to happen. We're going to compute what would happen if we increased the tuition by 6%. So what we'll need to do is compute 6% of $2,000 first. So we're going to add that number to last year's tuition. So let's start by computing 6% of $2,000. And just like in the previous problem, we know that we just multiply the whole amount times the percent. And that's what we'll call the amount increase. I'll abbreviate that like this. It's the amount increase. And when we compute this out, we get 120. Now, these are measured in dollars. Let me just put the dollar sign on the right. So this is $120. Okay, so this is not the answer, right? I mean, we wish it was the answer. If tuition increased and now it's only to be $120, fantastic. But that's impossible. If the tuition is increasing, we know it has to be more than this. This is the amount it increased. So to find the next year's tuition, we need to add this to the 200. Is the 2,000 plus 120. So it'll be 2,120. And that is measured in dollars. You'll notice I wrote the dollar sign on the right over here, just because usually we put our units on the right. Dollar signs are weird, and people put them on the left. And the final answer, I put it on the left because that's how most people write it. But if you ask me, we really should put it on the right. Every other unit that we use, we put on the right. Now, I want to say a little bit more about this. When we took this number, 120, and added it to 2,000, you can see that you can use a little bit of math and see something else here. This is the computation that we did. This will give us this amount. But what we can do here is we can factor out the 2,000. And when I factor out 2,000, I see that this, what's left over here, just becomes 1.06. And so this is another formula to get to the final answer. If you ever want to increase an amount by 6%, you can multiply by 1.06. If I wanted to increase an amount by 43%, I'd multiply by 1.43. So this is another way to get to the answer. And it is a little bit quicker, isn't it? Instead of doing 2 steps, I can do it all in one fell swoop. But in either case, you're going to get your answer to be this quantity right here. This is a very closely related problem, but here we're doing something slightly different. It says a shirt is marked off 20% off. If the original price was $45, what is the sale price? Okay, well, it got marked 20% off, so we're going to take 20% of 45, and we're going to reduce the price by that amount. So the new price is going to be less than this, which means we're going to subtract 20% from it. So first, let's compute 20% of 45. And I'm going to call that the amount decrease. And I'm going to multiply that by 45. And what do you get when you multiply 0.2 times 45? You get 9. So the amount of decrease, the part that we're taking off of the $45, is $9. So what we're going to do to get the final answer is we're going to take 45 and subtract the 9. So we can see that the sale price is $36. Now let's do the same thing we did before. Let's take our computation here and realize that 9 is really the same as 0.2 times 45. But now I can factor out the 45. And just as before, when we took to compute a percent increase, we took 1 plus the percent. To do a percent decrease, we take 1 minus the percent and multiply it by the number. And so that's another way to get to the answer. Take 1 minus the 0.2, then multiply it by 45, and you'll get to the same thing. But in either case, no matter how you do it, the final answer is $36. All right, here's a slightly more advanced problem. It says Alan paid $50 for an item that was 20% off the sales price. What was the original price? So we want to find the original price. So for this problem, I think it'll be useful to set up an equation with a variable. And the variable you always want to have equal to what you're looking to find. So we'll let x be the original price. Okay, well, if x denotes the original price, we know how to compute 20% off of it, right? We take x and we multiply it by 1 minus 0.20. And we know what that gives us, right? If I take 20% off of x, we know we get the sales price, $50. So here is the equation that we need to solve to find the answer here. Well, 1 minus 0.2 is 0.8. So we could write this as 0.80x equals 50. I swapped the order of these. I put the number on the left. That's conventional. And so we're solving for x, so I'll divide both sides by 0.8. Okay, maybe we don't want to use a calculator on this. You could use a calculator at this point, but I'm just going to do it. I don't have one handy, so I'm going to write this as a fraction. That is 8 over 10, right? But dividing by a fraction is the same thing as multiplying by its reciprocal. So this is the same thing as 50 times 10 over 8. And that's the same thing as 500 over 8. 500 and 8 are both divisible by 4. And 125 divided by 2 is 67.5. And there's our answer. The original price was $67.50.